All right, let's take a look at our lesson for today. So this is actually our first lesson on parametric equations. We have been working with vectors. Before that, we worked with polar. Parametric equations, and it may be the first time you've ever worked with parametric equations. It's most likely, maybe not, but probably. So let me let's go back and explain what is a parametric equation. So a parametric equation, and we're in 2 dimensions, we're not doing 3-dimensional parametric equations. I know you're upset about that, you really wish we were, but we are just doing 2 dimensions. What we have is a pair of equations. We have a pair of equations that express the x and y coordinates in terms of something called a parameter. For us in this course, our parameter is going to be t, which is time. Okay, that's our parameter. It's actually a thing. There are certainly other parameters, and I won't get into the other parameters. If you're really excited to know about them, I could tell you, but there are other parameters besides time, but those are in more later follow-on courses like multivariable. In multivariable, we have other parameters besides time, but that's about the first time you see other parameters besides time. So what does that mean? So let's take a look at what the set of ordered pairs looks like. So we would have the ordered pair. We would have like an x equals f, a function of t, and we have a y equals a function of t. So the x and the y are represented as t's. They're basically functions of t's. That's a parametric equation. It's actually a set. It includes 2 equations, an x equal and a y equal equation. So for the x equal equation and the y equal equation, okay, they're called parametric. We're doing vocabulary right now. We're just doing vocabulary. They're called parametric equations. T is called the parameter. And that capital I, they're calling it the parameter interval. That is basically our restriction. It's the restriction on t, on the variable t. It's the restriction on t. Now, the interval could be infinite. It doesn't have to have an actual restriction. The interval could be from negative infinity to infinity. If you look at our first example, this restriction, the parameter interval is from -2 to 2. So it just depends on which one you're working on as to what kind of parameter it has, or what kind of interval the parameter has. All right. So there are some benefits of using parametric equations versus Cartesian equations. We have more detail. If you look at this example up here, I said, for example, if a football is kicked for a field goal, both the horizontal, which would be x, and the vertical, which would be y, positions are dependent upon time. So we have more detail. There's more detail in parametric equations than there are in Cartesian equations. That's a benefit of parametric equations. Our goal today is simply to start graphing them. We're just going to start graphing parametric equations. We're going to do this by hand. At the end of the lesson, I'll show you how to use the calculator should you want to check your work or graph something even fancier than we're graphing. Our graphs are going to be pretty straightforward. So any questions so far on just the vocabulary about parametric equations? Okay. So let's graph our first one. So what I would recommend that you do is, we use something like a t-chart. It actually has more than just 2 columns. It has 3 columns. I call it a triple t-chart. I don't know. I don't know that it has an actual name. But what we want is, so we want time to be one column. We want x to be one column and y to be one column. So our additional column is time. Our parameter needs its own column. In this case, our parameter is restricted from -2 to 2, and I like to just use like integers when I'm graphing. Do you have to? No, you could use fractions if you wanted to, but you need enough points to get a good idea of what you're graphing. Okay, for me, I'm just going to start at the beginning time, which is -2, and I'm going to go all the way to the ending time, which is 2. It's important to definitely do the beginning and ending times. You need those. So we're going to do those. Now, some students are a little hesitant about time being negative, and I want to assure you that it's okay for time to be negative. We can think of some scenarios where time is negative. Let's say, I don't know, why am I thinking about food? I don't know, let's say dinner time. Dinner time is times equals 0 tonight. Let's just say you going to dinner is time equals 0. Well, right now would be negative time, right? Because we're not to dinner yet. And after dinner would be positive time. So that's just like whatever your reference point is, it depends on whether time is positive or negative. And so I just want to assure you that it's okay. Now, what I like to do when I'm filling out my little charts, my triple T charts, is I like to do one column at a time. You don't have to, you can do a point at a time, but I just kind of want to, I want to start with the X column and I want to finish it. So that's what I'm going to do. I'm going to start with the X column, I'm going to finish it. So I'm going to plug in a -2 for T. So I work that out, I get what? -2 times 4, so that's what, 12. So then I'm going to plug in a -1 for T. -1 times 1, 1, so that's a 3. Okay, 0 is 0. 1 times 3 is 3. And 2 squared, that's 4 times 3 is 12. You don't have to show any of this work. You do need to show your T-chart so I can see what you're doing. But you don't need to show that. You can do all the calculations in your head if you would prefer. So let's do our y. Let's work on the y components. So I'm going to plug in the t of -2 where the t is. That gives me what, a -4. Then I'm going to plug the t of -1 in. That gives me what, a -2. Then 2 times 0 is 0. 2 times 1 is 2, and 2 times 2 is 4. Okay, so there's our T-chart. So let's get an idea of what our maximum x values are. It looks like x is going all the way to 12. So I need to be sure, like, I'm all the way to 12. Okay, what other x? So I have a 3. I think that would do, because my x values that I need to plot are 0, 3, and 12. So I think that's okay. The y values I need to plot, looks like from 4 to -4. So I'm just going to count those up 4 and down 4, just to get a feel for the graph before I start graphing it. All right, so our first point is, and let me just, like, I don't know, underline it for you. This is the point that we're graphing, 12, -4. So we go over 12 and down 4. And these instructions don't say, but most of the instructions are going to say to label your beginning point. So this is the beginning or start. I think it's usually start. That's the start of the graph, and label and actually put the point, which is 12, -4. All right. So the next point is 3, -2. Puts us about here. Now let's think about, we just got finished working with vectors. Remember how vectors have, they have a direction? Remember that? Parametrics are also directional, which is another benefit of using parametrics. We're actually going in a specific, direction. In this case, we're headed left. And you really need to show which direction you're going in by putting one of those little arrows there. Now, I'm not going to, put a restriction on the number of arrows. I've had students that have drawn so many arrows, it looked like, it looked like feathers or something. I mean, they just are all come off everywhere, or like a little, But just a few arrows is enough to show me which way your graph is going. But you can do as many as you want. All right, so our next point is 0, 0. And why the printer just decides to come on and make all that, I don't know. I really don't know. I'm like, thanks, little printer. Okay, so let's see. Our next point is 3, 2. Oops. And then our last point is 12, 4. And so we're going to write end and write the point 12, 4. All right, that's our very first parametric graph. How's it going? Is everybody okay? Yes?
So if you already have like an arrow going in that direction, you don't have to put like a new arrow for
You
each
don't.
point. Okay.
No. You can if you want to. I mean, it's really a preference. It's whatever you would like to do. I need at least 1 or 2 to make sure I know which way you're going, but that's enough unless you just want to. I mean, some students actually like to put 1 at each point, and that
could go in either point, doesn't matter. Just
no,
random.
Just random. Yep, wherever you want, just so I know which way you're going, where you're beginning and where you're ending, and which way you went. Yep, we're good. All right, other questions? So this actual graph, we haven't really talked about these yet, but this is like a sideways parabola. Can you kind of see how that would be a sideways parabola? Mm-hmm. That's what this is a sideways parabola. We'll talk about those after Christmas break, but that's what that little guy is. So let's go and look at our next ones we're doing by hand. And so these have trig functions. And what I would like you to think about is we just actually finished working with trig functions and graphing them in polar form. Remember that? In polar form. Do you remember, let's kind of think through this. Do you remember what kind of graph when we were in polar would like 4 sine theta make? What kind of graph was that? Do we remember? And if we don't, it's okay. It's a what? With a double angle, yes. What about a single angle? Do we remember those? We didn't do very many of those, I guess. Those are just circles. Remember the 4 sine theta was a circle and a 4 cosine theta was a circle in a different place. They were just circles. In parametrics, it's pretty much the same. This is going to create a circle. I just want you to get a kind of a thought process on where this is coming from so that's not a surprise. Okay, so this should be creating a circle for us. Now, we do have a parameter restriction. Our restriction goes from 0 to 2 pi. So that's it, 0 to 2 pi. And I want you to notice something. I want you to notice, think about the unit circle. What is cosine on the unit circle? Is it x or y? It's x. And here, cosine is paired with y. That's a strange thing, and I want you to, as we graph this, perhaps you will be able to determine what strange thing is happening because I'm going to call it mismatched. X is going with sine and y is going with cosine. That's mismatched, and that's going to affect some future lessons of ours. So it is an important concept, but I'm not going to just tell you. I want you to kind of think through, maybe as we are, once we finish the problem, you can kind of tell what is happening. So I'm going to do a triple chart. And since we're with radians, I really just want to do the quadrantals. Y'all remember that, like the x, y, all, the quadrantals, like 0, I want to do 0, like pi over 2, pi, 3 pi over 2, and 2 pi. I don't really want to get into pi over 4s or anything like that. I just want to do just the basic ones that we typically do when we're graphing with trig. Okay, so we start with the x. I want to start with the x column first just because it comes next. So sine of 0 is 0 and 4 times 0 is 0. Sine of pi over 2 is 1 and 4 times 1 is 4. Sine of pi is 0 and 4 times 0 is 0. Sine of 3 pi over 2 is -1 and 4 times -1 is -4. And then sine of 2 pi is 0, so 0 times 4 is 0. Is everybody okay how I came up with the numbers in the x column? Okay. Let's work on the y column now. So we're going to do cosine. So cosine of 0 is 1. 4 times 1 is 4. Cosine of pi over 2 is 0. So it gives us a 0. Cosine of pi is -1. So 4 times -1 is -4. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1, so 1 times 4 is 4. All right, so here we go. So let's read the directions. So we love directions, don't we? Even if we don't love them, we have to read them. We want to describe the direction of the curve using arrows. Okay, well that's normal. We've done that before. We did that on the first one. We want to note the exact starting and ending points with ordered pairs. Okay, we did that on the other one too. That's just the same as we did the other one. So I just need to remember to do that. Okay, so our first point is 0, 4. So 1, 2, 3, 4. There's 0, 4. And that is start. And that point is 0, 4. Okay, our next point is 4, 0, 2, go back, 1, 2, 3, 4. Okay, and I'm going to indicate direction just so I don't forget. The next point is 0, -4, 3, 4. Okay. Then our next point is -4, 0, 3, 4, okay. And then our final point is 0, 4. That takes us back. So that's the start and the end. Start and end. Now it is a circle. Okay, we were talking about that it should be a circle. Do you see anything kind of strange about this circle? And what I'm speaking of is the way the arrows are pointing. It's going clockwise. Is that what we normally do in trig? No, we go counterclockwise. You need to write this down somewhere. You need to write it down because it's going to be significant. When we mismatch the x with the sine and the y with the cosine, it's going to cause the graph to rotate clockwise. So if you mismatch, x goes with sine instead of cosine like it's supposed to, y goes with cosine. If you mismatch them, it will cause the graph to rotate clockwise. So if we wanted the graph to rotate counterclockwise, then we would have to pair x with what? Cosine, and y with sine. That way it'll go the proper way, which is, you know, counterclockwise. I'm just saying counterclockwise is the proper way. Okay. What do you think about the 0 to 2 pi? What did that, when we had 0 to 2 pi, we were able to complete the circle, right? If we had less than 2 pi, would we have a whole circle? No. So I want you to think about that when we're getting ready to do B and look at its time restrictions. Also, looking at B, so we are, let's just kind of make a point to circle this. This creates a circle. I mean, that's what it does. That pairing of x's and sines and y's and sines and cosines creates a circle. If we have additional, like plus and minus, see the 2 and the 3, if we're adding like that, something to the sine and cosine, that's going to create a little bit of a different shape that is, what would you like, elongated or squished. They're called perhaps ovals. You've heard them called ovals. We typically call them ellipses. So if you're adding and subtracting from cosine and sine, you're going to get an ellipse. Now, do you have to memorize that? No. I'm just trying to help you know what you're going to be drawing before you draw it. It's not something you have to memorize. You don't have to, but it would just be helpful if you knew what was coming. Okay, so now let's work on the T-chart for part B. Now, is everybody pretty comfortable with how I get the numbers on the T-chart? Or are y'all okay if I just simply fill it out? Is that okay? Are we good? I'm just going to go ahead, just for time's sake, I'm just going to fill it out. So my time, I'm going to do 0, pi over 2, pi, and 3 pi over 2. The x's that go with those angle measures, x starts out at a 5, and then x goes to a 2, then to a -1, then to a 2. The y's, y starts out at -3, then goes to a -8, then goes to a -3, and then to a 2. And I got those columns by simply plugging in those angle measures into the x and then into the y, just like I did on all the times before, okay? So just prepping to get my grid ready. My x's need to go out to 5, 1, 2, 3, 4, 5, and to -1. My y's need to go up to 2 and down to 8. 1, 2, 3, 5, 6, 7, 8. Okay. So here we go. So let's start. Our first point is 5, -3. 1, 2, 3, 4, 5, -3. And that's our start. And that point is 5, -3. That's our start. Okay. Our next point is 2, -8. We're headed that way. Our next point is -1, -3. Then we go to 2, 2. And that's our end. Our end is at 2, 2. Okay. How come I didn't get to finish my ellipse? Yeah, because of this right here, it stopped me. This interval, this restriction stopped me at 3 pi over 2. How much more would it have taken me to finish? To 2 pi, right? Just regular, 0 to 2 pi would have let me finish. Okay. All right, so now what we're going to do is we're going to navigate to our calculator. Okay, so let's move to our calculator. I just want you to be comfortable with knowing how to. So in our calculator, I just want to highlight these because I'm getting ready to have to cover this up because I need to pull my calculator up. I want to kind of highlight some of these concepts. So we need to be in a graphing document. Okay, when we're in the graphing document, we need to press the menu. And the menu is then from menu, we need to go to graph entry, edit, and then to parametric. Okay, when we're using this feature, this is very important, ladies. I want to point 2 things out to you. And I did in the previous class, and I still have some students get mixed up, so please listen. There are 2 things that are important. One thing is that you have to use the T in the alphabet list. Do not use the X. It won't graph. I just won't. You have to use the T in the alphabet, not the X. The other issue is you have to be in radian mode. I'm just going to highlight it in pink. Be sure you're in radian mode. If you are not in radian mode, you're not going to be able to see the graph. So 2 things once you navigate there. Be in radian mode and use a T. Okay, so let me pull up the graph. So we are going to add a graphing page. So we click here, add graphing page. Okay. Now I'm going to go to my menu. And I'm going to go to number 3, graph entry. And I'm going to navigate to parametric, number 4. We're going to do parametrics. And it just pops this up for us. I want you to notice some things before we start graphing. Look at the T restrictions that are right here. T is automatically restricted from 0 to 2 pi. If you want that changed, you have to physically change it here. Okay? You need to, like maybe you're going -2 to 2 and you want to go to change it -2 to 2. And I'm just going to caution you to leave the T step alone. Let me explain why. What the T step is doing is it's telling the calculator how many pixels to print for you. Okay, if you make that number really, really small to make a much more precise graph, it's going to take an eternity for it to graph. Just saying. I have had students before, I don't really know why, that they had races on how slow they could graph. I'm thinking, what? Okay, all right. Likewise, don't make that number really big, because if you make that number really big, it's just going to stick a couple of points up there and you're not even going to be able to tell what graph you're graphing. So I really just encourage you to leave it alone. But I know some of us are daredevils and we're not going to want to leave it alone. That's okay. You can play with it if you want to, but I'm not going to. All right, and it needs to be, please be sure you're in radians. Radians. All right, here we go. So we're going to do sine. So we've got the trig. We've got sine of 2t. And again, you've got to actually press a t, which I know is weird, but that's the way it works. And then you want to, are these matched up right? Nope. 2 cosine t. Okay, they're mismatched. Oh well. And now I'm going to hit enter. And it actually graphs so fast that it's hard to tell. If there is a way to slow it down, I'm not as familiar with this calculator as I am with my old one, but there is a way to slow it down so you can actually see which direction it's going in. But that's kind of cool, like a figure 8. I mean, that's kind of cool. So that's what that creates. So let's go to our document and just sketch it. Just kind of put it in there. So it looks like this at the y-axis is like up 2 and down 2. And on the x-axis, it goes to 1 and -1. It doesn't pass that. You might be able to surmise why with this 2 and that 1, but okay. So let's do, so this would be like 1 here and here, and like 2. Okay, so kind of like, oops. Okay, sorry about the horrible graph, but at least it has the idea. So let's, and maybe you want to play with the parametric graphing. I don't know, it's kind of fun. These graphs are identical except for the sine 2 is a sine 3. So I'm just going to go in, and instead of doing another graph, I'm just going to hit tab and then use my arrow to scroll up. I'm just going to go over here and change the 2 to a 3. Ah, now that kind of looks like a wrapped piece of candy to me. Okay, I like candy, so maybe that's why I think. But doesn't that kind of look like a wrapped piece of candy? Yeah, for sure. So, okay, so I am much worse at replicating this than I am the other one. I'm just going to warn you. I'm going to try, but the last one I tried kind of looked like a deformed snowman. So I'm just giving you fair warning. I'm going to do my best. I'm going to try. Okay, so 2 and 1. I don't know, it kind of... Okay, this is not good. Okay, so that's about as close as I can get. I'm sure your graphs look way better than mine. All right.